Hi there everyone. Welcome back to the new session. So in this video we are going to discuss about Newton's backward interpolation. So in Newton backward in a difference formula useful for only uniform or equal intervals only. We can use it only for equal intervals problem alone. The formula is used to interpolate the values of y near the end of the table value, and also for extrapolation the values of y short distance again. If we are finding we are using this formula for finding y value, so require x near to xn and use the notation as delta. So we have the formula for Newton's backward interpolation is y is equal to f of x naught plus uh, which is equal to y naught plus u by 1 factorial delta y naught plus u into u plus 1 by 2 factorial del square y naught u into u plus 1 into u plus 2 by 3 factorial delta cube y naught plus u into u plus 1 into u plus 2 into u plus 3 by 4 factorial into delta power 4 y naught plus and so on. So where here u is nothing but x minus x naught by h. So here h is an interval length. So let us have the first problem under this category. The population of a town in a decennial census was as given below. Estimate the population for the year 1926. Look at the table, years in x, population in y. So they are asking to find out the census of the particular year 1926. Look at the x data. So this is near to the last, this is lies between the last two datas, right? So 1926 lies between 1921 and 1931. So therefore this value lies at the end of the table. So in this case we need to use the Newton's backward interpolation formula. For suppose it's lies in the middle of the table, means you can go for either forward or backward. At the beginning of the table means you must use the Newton's forward interpolation. In this such case, this lies at the end of the two data. So therefore here I am applying Newton's backward interpolation formula. In the solution, uh, look at the table in the given problem. The number of datas are 1, 2, 3, 4, 5. So therefore n is equal to number of data. So we are going to form the difference table for the given data. So take down the x datas and f of x datas. F of x is nothing but y. So x datas are 1891, 1901, 1911, 1921 and 1931. Like away the corresponding y values of 46, 66, 81, 93 and 101. So at the end of the table in the upward direction, the values are this I want to take it this as x naught and this as y naught, here this as delta y naught, this as del square y naught and this as del cube y naught and this as del power 4 y naught. Before that we need to know how to frame the difference table. This is called as difference table. For the notation of the difference table we are using as del y, del square, del cube y, del power 4y, like that. And for finding this delta value, so look at this y value. You have to subtract the first from the second. 66 minus 46 value is 20. Middle of this two data we need to enter this 20 and come to the next. 81 minus 66, that is nothing but 15. Middle of these two I need to put this 15 and 93 minus 81 is 12. Middle of these two is I need to enter this 12. Like away the last minus the 93. 101 minus 93 is 8. So this is the value of delta y. So the last data of delta y is delta y naught. Like, we are move on to the next column. So here also 15 minus 20 is minus 5, and 12 minus 15 is minus 3, 8 minus 12 is minus 4. At last I am having minus 4. No, this is called del square y naught. So this table is delta square y. Next, delta cube y. So for that also we are doing the same process. Minus 3 minus 5. So minus 3 minus of minus 5 is plus 5. So it becomes 2. And minus 3 minus of minus 3 is plus 3. So therefore this gives the value minus 1. So this is the value of delta cube y. So at last value I am going to take it delta cube y naught. Like my I'm doing the next column. So minus 1 2 is minus 3. So this is nothing but delta power 4 y naught. Suppose I may getting 0 for all the entries at delta square, means we have to trim the table at the level. It seems here I'm getting up to the last one. So therefore, like a way, we need to form the difference table for all the problems. So now we know very well what is the Newton's backward interpolation formula. Y is equal to f of x naught in plus u, h is equal to y naught plus u by 1 factorial delta y naught plus u into u plus 1 by 2 factorial delta square y naught plus u into u plus 1 into u plus 2 by 3 factorial into delta cube y naught plus u into u plus 1 into u plus 2 into u plus 3 by 4 factorial into delta power 4 y naught plus etc., where u is nothing but x minus x naught by h. I am trimming the formula up to the fourth because I am getting the value up to the fourth order. That's why. So now to find f of 1926, we need to find out the census at the year 1926. Here x naught is the initial value of x, that is 1891. Sorry, x naught, we are taking x naught is the end of the table value of x, that is nothing but 1931. This is y naught. This upward direction we need to take the data. So x naught is equal to 1931 and h is equal to 10. So look at the table. Difference of x data is the h value. So 1931 minus 1921, difference is 10. Here also 1921 minus 1911, difference is 10. Here also difference 10. Here also difference 10. So therefore difference is x data difference is called h. So h is equal to 10. And y naught is from the table, y naught is 101. And x is equal to what value we need to find, that is called x, that we need to take as x. So 1926, this particular value only we are going to find. So this is x value. So the corresponding y value we are going to find. So therefore u is equal to x minus x naught by h. X minus x naught by h is 10, which is equal to, after simplifying this I will get minus 0.5. Substituting all those values into the above formula gives y is equal to f of x naught plus uh. So this is nothing but minus 0.5. Now, so the initial value y naught from the table I am getting 101 and plus u value minus 0.5 by 1 factorial into delta y naught from the table I am getting delta y naught is 8. So this is 8 plus u into u plus 1 by 2 factorial into del square y naught value, delta square y naught value is minus 4 plus the next term u into u plus 1 into u plus 2 by 3 factorial into delta cube y naught value, that is minus 1 plus the last one u into u plus 1 into u plus 2 into u plus 3 by 4 factorial into delta cube y naught. After simplifying these things I will get so f of minus 0.5 is equal to the first term 101 minus this simplification is minus 4, and this simplification value, third term simplification value 0.5, the fourth term gives the value 0.0625, at last the term gives 0.1172. altogether I'll get the value of y is equal to 97.6796. This is the value of corresponding x value 1926. Let us move on to the next problem. Find f of 5.8 from the following data using Newton's backward formula. Problem itself they would have mentioned use Newton's backward. So anyway, you have to check x is 5.8, no? 5.8 is lies between the last two datas, so obviously we need to use the Newton's backward. Number of datas are 7, so therefore here n is equal to 7. Now let us form the difference table at first. So take the x datas and y datas and find out delta values. First column delta y. So how will you find out delta y value? So look at the y datas, x1 minus y1 minus y0, and then y2 minus y1, like away we need to subtract second value minus first value, third value minus second value. So the corresponding answer must be present middle of these two. 185 minus 176 is 9, 194 minus 185 is 9, and 203 minus 194 is 9, 212 minus 203 is 9, 220 minus 212 is 8, 229 minus 220 is 9. So this is nothing but delta y naught. And let us move on to the next column, del square y naught, delta square y naught. The same process we are doing. 9 minus 9, 9 minus 9 0, 9 minus 9 0, 8 minus 9 is minus 1, and 9 minus 8 is 1. This is nothing but del square y naught, delta square y naught. Next column, delta cube y. So 0 minus 0, 0 minus 0 is 0, again minus 1 minus 0 is minus 1, and 1 minus of minus 1 is 2. This is delta cube y naught value. So next del power 4y column. So 0 minus 0 is 0, minus 1 minus 0 is minus 1, 2 minus of minus 1 is 3. So this is nothing but delta power 4y naught. Let us move on to the delta power 5. Minus 1 minus 0 is minus 1, 3 minus of minus 1 is plus 1, that is become 4. This is delta power 5y naught. So 4 minus of minus 1 is 5, this is del power 6. So we are getting the value up to del power 6. We need to develop the formula up to the 6th term. So look at the formula. Newton's backward interpolation formula: y is equal to y naught u by 1 factorial delta y naught plus u into u plus 1 by 2 factorial delta square y naught plus u into u plus 1 into u plus 2 by 3 factorial into delta cube y naught plus u into u plus 1 into u plus 2 into u plus 3 by 4 factorial into del power 4 y naught plus u into u plus 1 u plus 2 into u plus 3 into u plus 4 by 5 factorial into del power 5 y naught plus u into u plus 1 into u plus 2 into u plus 3 into u plus 4 into u plus 5 by 6 factorial into delta power 6 y naught, where u is nothing but x minus x naught by h. Now to find f of 5.8, here x naught is 6. Look at the table, x naught is 6, y naught is 229, and h is equal to difference of x value, x data, that is 1. 6 minus 5 is 1, 5 minus 4 is 1. So it must be equal interval, then only we can able to use the backward. So you can check any one of the interval, that's enough. So and x is equal to 5.8 here. What we need to find? F of 5.8. So therefore x is equal to 5.8. So therefore u is equal to x minus x naught by h. X minus x naught by h is equal to minus 0.2. Now substituting all those values into the formula, the above formula, we get y is equal to 229. This is y naught plus u into delta y naught by u value, u is minus 0.2 by delta y naught value is 9 plus u into u plus 1 by 2 factorial into del square y naught, u into u plus 1 into u plus 2 by 3 factorial into uh, del delta cube y naught. Delta cube y naught is 2. U into u plus 1, u plus 2, u plus 3 by 4 factorial into delta power 4 y naught value is 3. U value u plus 1, u plus 2, u plus 3, u plus 4 by 5 factorial into delta power 5 y naught. Like u plus 1, u plus 2, u plus 3, u plus 4, u plus 5 by 6 factorial into delta power 6 y naught, that is nothing but 5. So that is missing here, so that will come into 5. So therefore after simplification gives the first term value 229, the second term gives minus 1.8, the third term value minus 0.08, the fourth term value minus 0.096, the next one is minus 0.1008, the next one is minus 0.102144, the last one is minus 0.102144. So therefore after simplification gives y is equal to 226.718912. This is the value of the corresponding x value 5.8. So look at the next problem. From the following table of half yearly premium for policies maturing at different ages, estimate the premium for policies maturing at the age of 64. 64 lies between the last two datas. We must use the Newton's backward interpolation formula. Here the number of datas are 5. First we should form the difference table. So take down the x and y given datas for the first two columns. Find out the delta y, delta square, delta cube, etc. values. The third column after immediate y is delta y value. So for that we need to subtract x1 minus x0, x2 minus x1, like that we need to subtract. 96.16 minus 114.84 value is minus 18.68. Like a way we need to complete this column. And come to the next one. Now we are getting delta square y is equal to minus 12.84 plus, because minus of minus is plus, so therefore plus 18.68 is 5.84, and minus 8.84 minus of this is plus, so they will get 4, and 6 plus 8.84 is 2.84. So like a way we are doing the next delta cube y naught, that is minus 1.84, 1.16. This is nothing but delta cube y naught value. So after doing delta power 4 we will get 0.68. This is nothing but delta power 4 y naught. At the end values are x naught, y naught, delta y naught, del square y naught, delta cube y naught, del power 4 y naught. So we are using these values into the Newton's backward interpolation formula. So this is the Newton backward interpolation formula up to the delta power 4 y naught. So after using that, we need to find out the value of x. X is equal to 64. Y value at x is equal to 64. Here x naught is equal to 65 and h is the difference of x data, that is 5. And x is equal to 64 and x naught equal to 65, and u is equal to x minus x naught by h, that gives minus 0.2. I am going to use all those values into the above backward interpolation formula, so I will get this structure. After that I am simplifying each and every term separately. I will get the values of 68.48 plus 1.2, this is the second term value, minus 0.4544, this is the third one. At final one gives the value 0.33408. And this fourth term, the last one gives 0.548352. So altogether the simplification value is 70.108032. This is the value of x is equal to 64. So let us move on to the next problem. The following table gives the corresponding values of x and y. Construct a backward difference table and express y as a function of x. Also obtain y when x is equal to 2.5. x and y data are here. Here the number of data are 5. Form a difference table for the given data. Take down the first column as x data and second column as y data, and followed by we are going to find the columns are delta y, delta square y, delta cube y, delta power 4y, up to we are getting the single one. We are doing this process. Now delta y, so this is 10 minus 7 is 3, 13 minus 10 is 3, and 22 minus 13 is 9, 43 minus 22 is 21. Likewise, delta square, 3 minus 3, 0, 9 minus 3, 6, 21 minus 6, 12. And delta cube, 6 minus 0, 6, 12 minus 6 is 6, and delta power 4, 6 minus 6 is 0. At last values are x naught, y naught, delta y naught, delta square y naught, delta cube y naught, and delta power 4 y naught. Now we are having up to delta power 4 y naught values. Of course this is 0, no need to develop formula up to this. We have to trim the formula up to delta cube y naught, that's enough. Yeah, we have the Newton's backward formula here. Now we need to find out the value of y at x is equal to 2.5. Now x naught is equal to, from the above table we will get x naught is equal to 4, and h is the difference of x, that is 1, and y naught is equal to 43. So y naught is equal to 43. Now u is equal to x minus 4 by 1, because they are not mentioning. Of course u is equal to x minus x naught by h, that is equal to x minus 4. Substituting all the values in the above formula, we will get this structure. After simplifying this, we will get the polynomial term is x cube minus 3x square plus 5x plus 7. So we need to find out y value at the x equal to 2.5. So after replacing this x value into the above polynomial, we will get y is equal to 16.375. Likewise also we can simplify. Otherwise in the previous problems and all, here itself we are substituting x value. In this problem, finally after finding the polynomial value, we are substituting x. So this is also another way of simplification. So let us have the next problem. Find your polynomial of degree 2 for the data by Newton's backward difference method. So x data and corresponding f of x data. Plot this into difference table. Here the number of data are 8, n is equal to 8, x value and y value. So difference of x is equal to 1. All the intervals are evenly distributed. So this is evenly distributed one. So therefore you can able to apply the Newton's backward. And followed by x and y, we are going to find out delta y, delta square, delta cube, etc. So delta y value, as usual, we need to subtract back to front values, 2 minus 1, 4 minus 2, 7 minus 4, like that we will do for finding the delta y. For finding delta square also, from delta y we are subtracting like 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 4, like that. So after that, finally I will get delta cube, all the entries are 0. So no need to continue that, because all the entries are 0 means we have to stop here itself. So here the last value of x is equal to x naught. This is y naught value is 29, and delta y naught value is 7. Delta square y naught value is 1. So we are developing the formula up to delta cube. Here x naught is equal to initial value at the last value of x, that is 7, and h is the difference of x, that is 1, and y naught is already we would have seen the previous slide, that is 29. Now therefore u is equal to x minus x naught value by h, that gives x minus 7. So y is equal to f of x, that is equal to we are going to substitute all those values in the previous formula. I will get this structure. So after simplifying, this gives y is equal to 29 plus 7x minus 49 plus half times of this particular one. So this simplification gives y is equal to half into x square plus x plus 1. What they are asking to find? Find your polynomial of degree 2. So they are not given any other x value. So therefore So this is the corresponding polynomial of the given problem. Thank you.